Welcome to this video, where we will determine the impedance of an AC circuit. We will review key concepts and formulas related to series RLC circuits. First, let's practice some fundamental concepts. The total applied voltage V in a series LCR circuit is calculated by the square root of the sum of the square of the resistive voltage and the square of the difference between inductive and capacitive voltages. Remember, only the resistor dissipates energy as heat. As frequency increases from zero, impedance first decreases to a minimum at resonance, then increases. When the inductor coil has internal resistance R, total resistance in the impedance formula is R plus R. Finally, DC meters are useless because the average torque over an AC cycle is zero. If the voltage across the inductor and capacitor are equal, the net voltage across the LC combination is zero because they are 180 degrees out of phase. The total impedance for an RLC circuit with R equals 40 ohms, XL equals 40 ohms, and XC equals 10 ohms is 50 ohms. Standard SI units for inductance and capacitance are Henry and Farad, respectively. Current remains the same for RL and C in series. Impedance is the total opposition to alternating current, measured in ohms. The theoretical formula for a series LCR circuit is Z equals the square root of R squared plus the quantity XL minus XC squared. Experimentally, impedance is calculated as the ratio of total RMS voltage to total RMS current, Z equals V over I. We use AC meters because DC meters measure average values, which are zero over a full AC cycle. The total voltage is not the simple sum of individual voltages due to phase differences. For phase relationships, voltage and current are in phase in a resistor. Voltage leads current by 90 degrees in an inductor and lags by 90 degrees in a capacitor. Inductive reactance is directly proportional to frequency, while capacitive reactance is inversely proportional. At electrical resonance, inductive reactance equals capacitive reactance, and total impedance becomes minimum, equaling the resistance R. If the voltage across both L and C is 15 volts, the net voltage across the LC combination is zero. A capacitor blocks DC because at zero frequency, its reactance is infinite. The power factor, cosine of the phase angle, is 1 at resonance, indicating maximum power consumption. Remember that the resistance R in the impedance formula must often include the inductor coil's internal ohmic resistance for accurate results. Here is a quick revision of key LCR circuit formulas. Note the expressions for resonant frequency, quality factor, and bandwidth. At resonance, impedance is minimal, and the power factor is unity. The general impedance formula for a circuit with internal coil resistance is also provided. Thank you for watching this video. We hope this session on impedance of AC circuits was insightful and helpful. Please like, share, and subscribe for more educational content. At frequencies significantly lower than resonance, capacitive reactance is large, and the LCR circuit behaves predominantly like a capacitive circuit. If you decrease the capacitance, capacitive reactance increases. A phase angle of 0 degrees between voltage and current definitively concludes that the circuit is operating at electrical resonance. In the impedance triangle, the hypotenuse is impedance Z, the base is resistance R, and the perpendicular is net reactance. For a purely inductive circuit, the power factor is 0. If the AC mains frequency is 50 Hz, the current reaches 0 100 times per second.